Welcome back to the workshop. Now if you watched the last video, you'll see that it ended with me building this. You'll also have seen that I didn't really like it, so I went to redesign most of it, and now we've got these bits. So in this episode we'll machine a new Z-axis, including a better touch-off. We'll get back to what we usually enjoy on this channel, which is a little bit of machining. This is the Y-axis base plate, and then we'll wire up the stepper and give it a quick test run. So what I decided to do is keep the ball screws, keep the linear rails, but everything else downstream of that would go. And basically what I'd end up doing is replacing this bit with this assembly here. Yeah, that way around. Well, it's hard to see on camera, isn't it? So we've got some big holes there, and the idea of that is I had some of these lying around off a different project. They would be a nice fit into there, one top, one at bottom, and I'd have two of these, and so this would move up and down, and then this, you know, barely any friction for there, really smooth running. It'd be slightly spring loaded, but the touch off for the lower piece would be done with that. So I was much happy with that design, and what I did is to get those to be a nice fit in there, I 3D printed this square. I put a corner on it so I knew which hole was what, and each one is 0.05 bigger than the next one, just to find out what was going to be a nice size, just to give a nice push fit into the plastic in there. Because I know this is 3D printed, this is PET G, it's going to be right up against the rail, and then the other axis is going to be here. I think it's probably going to be robust enough to use for the final design. That's to get the cable harness in. That's for the proximity sensor. The other thing I'm experimenting with, you can see, I've actually tapped that M12 fine, so let's see how well that holds up. And then that one will have a little nut in it. That's going to be the proximity for the home. So all that stuff in there. Oh, and then the ball screw. Oh, I need to just take those out. There's three little holes there for the ball screw to screw in. So the ball screw will be permanently attached to that, and then the lift or touch off will just be via sliding those very easy to move rods in there. Okay, so that's that bit. And then, so we talked about that. Those will be in there. The rods will stick out the bottom. There'll be four of those, obviously. It'll be that way around the front. And then, now this piece, this is a temporary piece to see how it's all going to work. It does lots of different roles, but obviously we've got that pinch function there, so I mean, I don't know how well this is going to hold up even just for trials, but basically that will go in there. Ooh, it might do. Yeah, this will be machined in aluminium, don't worry. Yeah, okay. So I've even managed to get little heat set inserts in there to try and clamp that. And then that's the bit that when it goes down, that'll touch off, and you know, no force required for that, so hopefully that'll work. And then there'll be the proximity single sensor in the middle. These ones will hold M6. No, these will be for the like the pins, the tapered pins, like we had before, to allow it to self-center onto those. In fact, it will sit onto there, which holds the torch, and the pins will go into the center hole there. So there's three of those, so it kind of sit like that, and it'll always balance back. And then in the outer pair of holes, there'll be 6 M6 bolts with springs on each. So rather than having one spring pulling up only in the middle, I've got 6 around the outside. You've got a much bigger lever moment to try and control the torch. Hopefully the torch will stay in place under all main conditions, and if you hit something it will move, the sensor will detect that, and then you'll e-stop from there. So that is kind of it. So as you can see, I'm part way through. Still need to put a few bits and pieces together, but that is the basic idea of version 2. I think we'll start with these linear bearings. Now I've only got 2 of them. It should be a nice gentle fit. Ooh. So crack the plastic. Ooh, that is tighter than I was hoping. Oh well. Actually cleaning these up was a lot easier once I used the support material. So I got an AMS with 4 filament rolls on it. So this is PETG, the main material, and then for the support material I've used this PLA that came with the machine, and basically it stops everything sticking, so it's just yeah, it's kind of that white colour there. It makes it much easier to clean up, you know, to remove small parts where you're going to put heat set inserts. You can see the overall finish you get with that. You do still need to do a bit of cleaning up, and also it adds considerably to the print time. It can kind of double it or even more. I think this was a 5-hour print, but you know, because it does so many filament changes, about 60 changes every time it needs to put a little bit of this support material, but it really makes it nice. So one advantage of the AMS is you can have really nice finished parts that are easier to clean up. Right, let's put the heat set inserts in, and then we'll assemble it onto the rails. Okay, looks good. So a quick update. So I just turned these down on lathe, just to turn them to a 45-degree point. So we've got 3 of those, and then we've got some lock nuts to lock those off. And then what we'll have is pairs of these springs go through like that. And you have 2, 4, 6 of those, and then those, they're a loose fit in here to allow the lower plate to move around. Yeah, whatever. And then the springs will go through there and sit in there and spring load it all together. And then I've just tapped the centre there, M12. I don't know how we'll get on, but I made this quite thick, about 4 layers, and then just used the tap in the drill. That's the same tap size, I think it's M12 by 1. It's the same, it'll fit these proximity sensors, so that'll go in the middle. And then it senses on, got that little grub screw which you can adjust the height as well, but you can also adjust the height of that, and then probably get the idea by now. Oh, if I can get it back together. Okay, I've only got 5 of these fixings rather than 6, and I haven't quite got enough springs. Anyway, as we're kind of mocking this up and working out what's going to work, as I'll put these together. It's about as tight as I do. Alright, let's offer it up. I haven't got any springs yet. I'll have to order some at 12mm, but for now I can try out the basic idea. But obviously they're far too long. Oh yeah, that is, it's going to be next to no effort to move that up and down. Okay, let's get this back on. Alright, so it's a bit of a mock-up at the moment, so we'll have 12mm springs that are on there that will be pushing the rods down, and then up here they'll have some stop collars to stop this going any further. and obviously when then this Z-axis goes down, so that way, and unlike the previous design, this is completely attached to the ball screw, just in the normal way. This is connected to that block, but of course if you go down and touch off, this will come up and it'll be detected on there. So I need to decide which type I want. If I want it to be on now and then that off, or the other way around. But we've got two types, so we can sort that. Obviously I can adjust, once I've adjusted these three, because these are like 3 pins, so I can adjust the pins to get the torch level. Once I'm happy with that, those 3 grub screws, then that one back there, that one gets used for the touch off detection there, so I can adjust that to be in the correct position. And then this one does that collision detection, so just, how's that? Oh wow, that's not very stiff, but obviously we're going to replace that. But it can't drop the torch, so hopefully that will do it. And anyway, there's plenty of adjustment. Alright, pleased with that. So there's a few things to do. I've got to trim those to length, order some springs, machine up some stop collars on here so that this can't go any further down, order some more small springs, and I think I was short of an M6 bolt as well. Oh, and I've got I've designed this so this basically is the same, and then I've got to put some heatsink threads in there, and that'll go on there to hold the torch. So basically I'm happy with that. We'll just get those things finished and then we'll bring you back in a bit. You might be thinking, why have I gone to all this trouble? I mean, I've gone through all these iterations, so that was to get a heat set out of there, because I don't need that anymore. All these different iterations, some of the early level designs like that, and then a little nut driver as well. So I really want to get this bit right, because I don't really want to come back to it, and I know once I've got this right, because this is new, this is the new bit to me for plasma, once I've got back to here and I've got the stepper on here, and then this huge plate that this all sits on that runs on some more 20mm bearings, I'm back onto a gantry, big ball screws. I'll say actually there's still 1204, but usual CNC stuff. I think it looks fine in the CAD, and I think it's going to work, and that should be nice, hopefully nice and straightforward. And I've already printed out a lot of the parts that will make that come together quite nicely. So that's the status so far. Okay, so next up we need to machine the main plate that this sits on. That's the Y-axis. I've got the drawing down here. So nothing too complicated. We'll just spot these holes out on the CNC machine and then bore them out using an interpolation. And then we'll come back and clean everything up and tap these M5. We've got an M12 there to take the inductive sensor. And then that slot is where the drag chain fits on. It just gives me lots of positions to locate it laterally and get it aligned. And then there's a couple of holes for probably an electrical box that will take all the joints for all the cables, just so I don't run all the cables back down to the main control unit. Yeah, I think that's it. The main tricky bit might be drilling and tapping these on the end, which go onto the end there, and they're the screws that actually hold it onto the main vertical bit that you've just seen me make. But anyway, I'm sure we'll get past that challenge. So I've got the same big bit of stock over on the CNC machine, set up, ready to go. Let's run the program. Okay, quick update. The other two bearings have come in, so I've pressed those in at the top there, so that moves quite nice and smooth on there. And then I've reprinted this with a slightly different design to allow this new assembly to clear it like that. And I think that's it really. So let's put this to one side and show you the main plate that we just machined. Okay, so here it is all cleaned up. I've drilled out all the M5 fixings and then drilled that to M12, that's for the proximity sensor, and then basically just cleaned and deburred all the edges. So let's see. Now I'll have to strip this back down, so to get to the bolts they're behind here underneath the rail, so the rails have to come off. But that was okay, I knew that ahead of time, but I wanted to make sure that was going to go together before we went too much further. So let's just offer it up and see if it looks like it's going to fit. Let's put this on here for support. So it'll be bolted down there and there, same the other side, and then 4 into this bit. I think especially when that's machined out of aluminium, 3 pieces. Okay, a little bit of a progress update then. So I've taken the whole unit apart, as you can see down here. I 3D printed a few things, which I'll need later in the build. So this is a wire guide, so this will keep the cables neat as they run across the machine. And then this is a belt cover for this axis here. Hopefully that'll fit okay. And then while I was printing that cover, I designed one that will go over the whole thing, sort of down here somewhere, and it kind of lines up with that, and that allows the cables to go out there. The only thing I'm not so keen on is that I printed it with supports, and they've been really difficult to get those bits off there. So maybe I can print it in a different direction. If I use the support PLA, that will come away really easily. So turn this sort of 2.5 hour print into like a 6 hour print with about 200 changes. So yeah, perhaps, well, we'll have a think about that one. But the other major improvement is, you might remember this, and I 3D printed it. I wasn't too keen on that. Somebody did say I could have printed it a different way. So you can see I printed it there. Maybe if I'd have done it that way, that would have been better, but there would still be maybe some support there, depending on the overhang that it could cope with. But I decided I didn't really like this anyway, and we've done something better. Okay, so I've been busy machining this. So it's an aluminium version, so we've got 2 sides there. There's the front cover you saw me make a while ago, and the rails go on there, and the ball screw. And then we got the main carrier for the be the y-axis, won't it? So yeah, we were talking about that top plate. I decided actually I would keep that. That is really stiff. I can't hardly move it. It's pretty thick, as you can see, and the stepper motor will go in there. I've got the relief for the round part on the top, and it slides backwards and forwards, and that then will screw into those holes there. Okay, yeah, it's really starting to come together. So I think what we need to do next is we'll get these rails back on here, get the ball screw in, basically get all that reassembled onto there, and then we'll get this fitted again, and then I need to remachine this in aluminium. Now I know it's going to work, because that's clearly not going to be stiff enough just on that little bit there, just grabbing. So we'll make that again. But yeah, so much better. So much more robust, and then yeah, I think we'll get away with that. I think that'll be okay. Okay, so I think first, because I can't get the motor, once that plate's in there, I can't get the motor in there. It doesn't quite, so we'll get the plate mounted on top of the motor like that, and then just drop it on. And you can see how it's going to pick up those holes and allow it to slot. I did remember this time to put the little recess in there, so that raised part there can actually slide backwards and forwards. So let's make sure it's the right way around, which it is, because I want the cable coming out the back. So we'll get that sub-assembled onto there. Just these M6. Actually, I'll go and get some washers. Spread the load a bit. I often use M5, M6 for machines, but I dropped down to M4 just because I was going into 8mm section. I couldn't go any wider than that because there was not enough space to actually get the motor in as well. So everything's very tight, but it does fit. So I think if we get that plate, maybe I'll put some washers under, I don't know, let's just see how we get on. I don't know if we're going to be able to get a washer under here and get that to slide past. Now this is printed in PETG, and one of the things I'm a little bit worried about long term is any torque relaxation on that as the PETG maybe takes a set, I don't know. Yeah, if that happens, just machine a plate so it's not too big a job. But it's so easy to 3D print. You just hit go and walk away and do something else, or you can build a different bit of the machine, or you can do something else not related to the hobby. Just let it print overnight, whatever, and you come back and you just got all the parts as within reason, almost as complicated as you want to make it. But sometimes maybe aluminium is the better option. Right, let's get these mounted. So there's a flat D on that one. Just get it loose for now because I don't know exactly the final height. Okay. There's no flat on that side, but there's not going to be a huge amount of force. We haven't got the nut on there, have we? Yeah, because these are just some ball screws I had. I might have to machine a nut and a collar, but for now, hopefully it's stiff enough not to move. Okay, I just remembered I had some spare nuts and various collars that I'd ordered, so we'll drop those on. So normally a couple of these collars are used with the standard BF bearing, but because I've made my own, I've just got these standard ball races in there. I'm just going to use one just to get back, I think that's going to be enough, yeah, to the thread. And then we've got our standard, this is an M10 by 1, it's a bit of an unusual fine thread. And I don't have a tap for that, so I end up buying these nuts, but maybe one day I'll get a tap just to make sure I can make them if I get stuck. Okay. So at least that's so far. I think the next thing we need to do is get these rods cut down to the right size. I will remake that in aluminium. I just checked my stock and don't have anything it's just quite that size in 8mm, so I'll order something in. And let's take those stop collars off. And obviously we're not going to chop both down, so I think, yeah, let's put them both in, mark it, and then obviously I'll get both out of one of these. So probably just tilt it back is easiest. Okay, what I need to do is get this in the right position. I need about 10mm of travel, I think, just for the touch off. So that should be 17, which it is. That is the top. 100. Okay, there they are, an awful lot shorter. And looks like that one's moved. I don't want to do these up too tight. I thought I'd just try this out and see if it fell down under its own weight, or whether it's... yeah, see, sometimes it gets stuck, doesn't it? I know it hasn't got the torch on it yet. I think I'm going to need some very low tension or low compression springs on there just to make sure it returns back down again. Alright, anyway, for now, get these on. Yeah, it's going to need some light springs, but otherwise, probably a bit of grease in there wouldn't hurt. Alright. Yep, looking good so far. Okay, before we go too much further, I thought it would be quite good fun just to hook up the motor to a little stepper driver here. So originally I thought about just making up a little Arduino system, running some code on it just to put some pulses out into the driver and then just move the stepper up and down. And I thought surely somebody's made a system like this, and indeed they have. So this little board here is just for testing out steppers. So you've got, if you can see up there, but there's an enable, a step, a direction, then common 0 and common plus, the +5. It's got some little jumpers to do a coarse adjustment on the frequency. You can do PWM or frequency, which is what we want. You've got forward and reverse, on, off, and then you've got fine control of the stepper here, and then it just needs up to 24 volts here. So I guess on board it will be dropping that down to the 5 volts for the pulses, somewhere on that. And yeah, that was about £6 something on eBay. So I'll drop a link to this in the description below, because it's quite a handy little tool just for setting up systems like this and just playing around before you got your full control system in. So we'll wire this up. I've got my power supply. I think we can go up to 24 volts. Now it'll be low performance, but it'll be plenty good enough for just making sure it works. So we'll get this wired in and then let's see how it runs. Okay, so I've got it all wired up. So we've got 24 volts on there. We've got the 24 volts going into the driver, and then I've teed off that, put 24 volts into this little unit here. And then on the positive side, which is this one, they're all daisy chained together. And then usually on these you need to take the ground down for your switching, so the direction and clock there are in the negative ones of those. I'm not going to use the enable, I don't really need it for this setup. So I've just wired in the stepper motor into there, and I'm just triple checking that I've got some resistance. It should be a couple of ohms across each pair, A and B. It's very easy to damage these drivers if you get a short or anything like that, so it's critical you treble check those. So we'll just do one last check on that. Okay, so hopefully you can see when we plug that in there, A plus A minus is going to be one winding, so the first two, and then B plus B minus is the other winding. So we just need to make sure across the first two we've got 1.7 ohms, and the second two 1.7, and then we'll also just check there's no shorts or anything funny going on between any of the others. No, we're good. We've just got 1.7 there across the second pair and 1.7 across the first pair. Right, I'm happy with that. So I'll bring you in a bit closer so you can see how it's wired. These steppers down here, that's low, medium and high for the coarse sort of speed setting, I've got that on low, and then we've got PWM and frequency. I've got the little jumper there on frequency because that's what we need. We're not going to run these off PWM. And then I've just labelled it on the board there. You can see that's the common positive, which is that one which steps between them all, and then we're switching on the negatives of the pulse and the direction, and I'm not using the enable. And then there's the power up to 24 volts, and I'm just teeing that off the power that comes from the power supply, and then we just checked all those. So I think we're okay. I'll just double check these switch settings to make sure we're on quite a low current, so we don't pull too much current from the power supply. We're only going to move it up and down. There's no real load on it, and then we'll switch it on and give it a try. Actually, rather than just change all the switches, I just thought I'd show you those just in case you've not seen those and you don't know what they are. I'm sure you have, but here we go anyway. So the switch 1, 2 and 3 control the current, so it makes sense just to start at 1. I don't need it too high at the moment. 1, 2, 3, so they're all on. And okay, they're all on, so factory preset is the lowest current, so we'll leave that. Switch 4 is off, and switch 4 relates to whether you've got full current or half current. If you leave the motor idle for a few seconds, it will drop to half current just to stop this getting too hot, so that's off. That's what we want. And factory setting is off, yep. And then 5, 6, 7, 8 determine the number of steps per revolution, number of pulses. What were they? Off, on. And it's currently set to 400, off, on. So that'll be the maximum torque, but it will be a little bit noisy. Won't run that smooth. 1600 is quite a nice sweet spot to run these. So we want off, on. So we want that one off, on. Off, on. Yeah, that'll be 1600. Now for now it won't really change much, it'll just sound different and run at, really this will come into play once we get the software up to speed, and we'll need to give it that value so it's all calibrated, but for now it'll just make it sound a bit smoother. Right, here we go. Time to switch it on and see if it works. Got an LED. That's good. It's a little surface mount one. All right, let's just check we've got. I guess that means we must have 24 volts here. Yep, which we do. And I guess we're going to have 5 volts here. Yep, we've got 5 volts there. Should be common across all these. Alright. In theory, oh, we got a little, you can't see it on camera, a little green LED on the board as well. Yeah, maybe you can see it reflecting. Alright, so low, let's switch on. Oh, it's already going round. What does the off switch do then? Okay. What I'll do, just drop this on. So you can see something turning. That's nice, really smooth. Reverse, go the other way. Yeah. You get a little blue light when you're reversing. That's cool. But on off doesn't do anything. What? Alright. That is super smooth as well. And there's a bit of run out on these cheap pressed in belt guards. But yeah, nice. Okay. There's another look at the board. As you can see, on and off doesn't do anything. It's still going round. Alright. Forward and reverse, yeah. Alright, we'll switch this off and we'll go to the high and just see how fast we can get this thing to go. So it's all off, and now just need to move that jumper. Medium, high. Okay, we'll switch on. Make sure that's as low as it can go. Alright. So whether it's on or off, it's putting out pulses. Okay, I don't. Maybe that's on off for PWM. Who knows? Right, how fast can we go? Certainly stall it out, only on the 1 amp there, and we can hit the resonance as well, somewhere there. Or is that just the? Oh, it's just the pulley buzzing on there. It's quite a nice way to test steppers safely, so that they're not on a machine and you haven't got a computer and interface. Just messing about and seeing how fast they'll go, tuning it maybe. Actually, I do have a tachometer, don't I, so we can just see how fast it's going, but I can already see that's going to be plenty fast enough to whiz that up and down. We're on the lowest setting as well. Right, let's bring that down a bit. So I think what we'll do, we'll get the belt on and then just move this up and down, but I will put it on the lower speed for that. Alright, so we've got the, that's going to keep going round, isn't it? So we've got to be careful. Alright, I guess we can keep going forward and backwards. Right, let's switch on. It's moving across the desk. Yeah, because bit crude, but it will do. Alright, yeah, it's free to move now, so it's going down. They're definitely going to need springs, aren't they? Obviously we haven't got the home sensor yet. Certainly sounds nice and smooth, so if it comes down to touch off, it'll go like... yeah, that's going to need some grease on it, I think. Oop. And that's full speed on that setting. Nice. Oop. Be about the on-off, it doesn't stop. Right, I'll switch it off for safety. Okay, so I'm really pleased with the progress. I'm glad I redesigned this. I'm a lot happier with this. It still obviously needs a little spring in there just to make sure it comes back, but nothing too major. Bit of grease in there, I think that will be okay. I need to remake that. Pleased I made the sides. I think that was a good move. And the top, well, let's see how that performs. Can always remake it if that's an issue later on. Proximity sensor bracket, got that one sorted out, that's new. And obviously we've wired it into this little stepper driver. Never used this one before, but yeah, pretty pleased, apart from the on-off switch doesn't seem to work. The rest of it, yeah, it's a really useful bit of kit just for debugging, just setting up before you've made your controller. Okay, so we've got a few little jobs to finish off, nothing too major, and then we need to get onto the gantry. So I've got a big aluminium section little run past there, and it's going to have some rails and some linear rails, that is, and some carriages on there. Now, with a project like this, I don't know if you need to go to the expense of THK or Highwin or something branded like that. So I thought, from the shop I usually buy this on Aliexpress, this kind of linear rail system, I thought I'd try their really cheap system, and I've got it down here, and let me just show you that. Now, these are the lower cost ones from a shop I usually buy this sort of stuff off, Aliexpress. I'll leave the link to the shop that I buy linear rails and ball screws from. So the ball screws themselves are the usual thing. These are 1204 ball nuts, end machining, everything. You've got the little grease nipples, little caps that go on the end of those holes, nuts, spacers, all that kind of stuff. So that's all standard. But what's new, what I'm going to try out, I've got one here. Yeah. Oh wow, they're quite heavy. We're going to have a look next time at these low-cost linear rails. So I'll put the name on the screen and the picture of the name of those, BL something I think they are. Now, they're supposed to be 100% compatible in terms of hole spacing and everything else with the Highwin rails. So these are 20mm. That's a bit of a sneak preview of what the carriages look like. They've got this different, there we go. Did open one to have a quick check. You can't really see it, but the spacer inside is quite different, but the rest of it looks pretty similar. So, there's the name there. So we'll dive into these, and within the limits of what I've got in the workshop, next time we'll have a look and we'll test these and try and test them for accuracy and things like that, and give my thoughts on them. Obviously we won't know till the machine's fully running what these super cheap rails do, how they perform, but I'll do my best to give you some feedback, and it might help with a similar project you've got going. Alright, so let's wrap these away so they don't get any dirt and stuff on them, and we'll wrap up this video. Okay, well, as always, thank you very much for watching. I hope you've enjoyed this video. If you want to see more like this, feel free to subscribe, and if you don't want to miss the next episode, then feel free to click that bell so you get notification. Especially if you're interested in how I get on with those low-cost linear rails, we'll have a look at those in the next video. And with that, we'll sign off and say thank you very much for watching, and see you next time.